As a scientist, what are we studying? What is the main objective or thing we are trying to learn about? The correct answer is something else. The density of air at sea level and 98 degrees Fahrenheit is about 1.20 grams per liter. The volume of the adult human lungs in the expanded state is about 6.0 liters. Given that air is 20% oxygen by mass, compute the number of grams of oxygen in your lungs. Finally, we realize we're being asked about our lungs. We're trying to answer a question about a pair of lungs. So then we ask, what do we start our dimensional analysis with? The answer is something else. We will start with the one pair of lungs. Everything we do from here will be multiplying by conversion factors, used to convert from one unit to another. Therefore, we know from the problem that one expanded pair of lungs equals to 6 liters. So let's convert. Times 6 liters of air over one lung. Now we have the volume of one pair of lungs can contain when filled with air. Is that what the question is asking? No, we want the mass of oxygen, which is why the question asks for grams of oxygen, not liters. How do we convert from volume to mass? That's right, we can use the density of air to convert from volume to mass, times 1.20 grams of air per 1 liter of air. Notice that we're being careful to annotate our units. It's not just 1.20 grams per liter, it's 1.20 grams of air per 1 liter of air. Why is this important? If we would have just done this, we might think that we're done. We might think that this is the mass of oxygen, but it isn't. It's the mass of the air. So we're here. And we have converted from one lungs to mass of air in our lungs. But we aren't done. How can we get mass of oxygen? 20% oxygen by mass means that for every 100 grams of air, we have 20 grams of oxygen. That's another conversion factor. So what is the final step? The final step is 20 grams of oxygen per 100 grams of air. Altogether, this is 1.44 grams of oxygen. But wait, what about the temperature given in the original problem? Turns out it was not necessary information. That's okay. Since we made a picture of the problem, we weren't distracted by this unnecessary data. Which brings us to these two important big ideas. 1. Don't start by writing numbers or highlighting values. Start by making a picture, in your mind, or better yet on paper, of what the problem is describing. Identify the thing we are studying. 2. Be very specific with units. Just grams is ambiguous, especially when we're dealing with multiple things, which is almost always the case. Use grams of air or grams of oxygen. Be specific so that you don't mistake one substance for another.